Hi Scott. Hi Abhilasha. How are you?
Hi, Tanishka.
Hi, Tanishka.
Hello everybody. Welcome to our webinar on unlocking multimodal brilliance, enterprise use cases and innovation. I am Tanishka, and on the behalf of Walking Tree Technologies, I extend a warm welcome to each one of you. It is truly a pleasure to have such distinguished audience joining us for this exploration. Before we delve into the details of our agenda, let's take a moment to welcome those who are still joining us. For those who are unfamiliar with Walking Tree Technologies, we are pioneers in driving technological innovations, specializing in implementing state of the art solutions, particularly in emerging technologies like AI. At the conclusion of the webinar, we reserve some time to address your questions and insights. So feel free to submit your queries in the Q&A box during the session. Let's make this an interactive and enriching discussion. Without further delay, let me introduce our esteemed speakers. Beginning our agenda, so we have Scott Seabolt, our Chief Technology Officer, leading the way. With a wealth of expertise and forward-thinking vision, Scott is an ideal guide for exploring the potential of multimodal brilliance in enterprise context. His insights will offer participants a comprehensive understanding of multimodal language models, delving into real-world applications and use cases. Scott's expertise will provide invaluable insights into the strategies for implementing multimodal language models, setting the stage for a deeper exploration for their impact on an enterprise innovation. So, continuing our agenda, we are honored to introduce Abhilasha Sinha, our solutions architect, as a guiding force into our exploration of multimodal brilliance. With extensive experience and forward-thinking approach, Abhilasha is well suited to lead today's discussion. Her insights will provide practical strategies for implementing multimodal language models in the enterprise, drawing from her extensive background as a solutions architect. Abhilasha's expertise will illuminate the significance of multimodal brilliance in driving innovation within enterprises, offering actionable insights for leveraging these technologies effectively. Our webinar on unlocking multimodal brilliance, enterprise use cases and innovations aim to provide participants a deep understanding to transformation potential of multimodal language models in enterprise settings. Through real-world applications, strategic insights, and practical strategies, our distinguished speakers will explore the way in which multimodal brilliance can drive innovation, enhance user experience, and streamline operations within enterprises. Now, as our distinguished speakers take the virtual stage, let us embark on this journey together, unlocking the multimodal brilliance that promises to revolutionize enterprise landscapes. Over to you, Scott and Abhilasha.
Okay. Hey, thanks, Tanishka, for that introduction. So let's kind of get started here and do a little bit deeper dive into exactly, what these models are and how they work. And we'll begin that just by doing that, right? Introing, and then we'll deep dive into some real world applications and use cases, and then look at some strategies for implementing multimodal language models, and then we'll showcase some demos as well. So we'll try to save a lot of time to do those demos. I think those are very useful for many of you. So yeah, just kind of diving in there into, multimodal language models they can also be called MMLMs. Hard to say, but they're basically what it means that they integrate both textual and visual inputs to understand and generate content. And you'll also see them referred to as vision language models as well, or VLMs. So if you see that, that's kind of synonymous between the two, MMLMs and VLMs. And let's just take a look at, one of the key advantages of these models is their ability to combine different modalities, right? So things such as, such as text, images, even videos, and they're used to achieve really a more comprehensive understanding of the input data. And this fusion of modalities allows MMLMs to capture really richer context and semantic meaning. That leads to really an enhanced understanding and really more accurate outputs. Okay. Another important aspect highlighted on the slide here is that by analyzing both text and images, multimodal language models can capture more kind of nuanced and contextual information that go beyond what could be understood from just one modality. And I think it's worth in the bottom point there, it's worth noting that the term multimodal in this context can refer to various combinations of input and output input and outputs, and generates text, and as an output would still be considered a multimodal language model. So really what we see here and what we get here is just the adaptability of these models, and that's what really makes them a lot more so powerful, really, and widely used across different applications and different domains, different use cases, and we'll highlight some of those coming up. So now, now that we've kind of talked about what multimodal language models are, let's take a closer look at how they actually work under the hood. So, yep, oops, that's all right, Abhilasha, thank you. So as you can see on this slide, there are really kind of three key components here: encoders, projection layers, and language models. And the first step is to use an encoder for each data modality to generate embeddings. Okay, which those are essentially numerical representations of the input data. Okay, so that's what we're talking about when we talk about embeddings. And what this does is this allows the model to process and understand the different types of input in a unified way, right? The next component is the projection layer, which it kind of aligns to the embedding. It kind of aligns the embeddings of different modalities into the same multimodal embedded space. So this is a crucial step that enables the model to map the relationship and connections between the various input types. Okay. And finally, we have the language model, as you can see down at the kind of the bottom there. You see the picture of the dog. What is this? So we've got visual model, we kind of talked about, in all the embeddings, the projection model, and then looking at the language model itself. This is trained to generate text responses based on the multimodal embedding. So by conditioning its responses on both text and visuals, the language model can produce more contextually relevant and accurate outputs. So you can imagine that, if you're looking at something, you got a picture. Not only can you use the language itself, but you can also look at the picture and determine the context, a greater and more relevant context. So you can kind of imagine how that would be incredibly useful. And as we talk about use cases, I think you'll see that. It's, I think, important to note also that since, inputs can contain both text and visuals, the model needs to be able to handle generating responses that take both modalities into account. So this is where the power of multimodal language models really shines through. So I would say by leveraging these three key components: encoders, projection layers, and the language models, MMLMs are able to process and understand really complex multimodal inputs, and they can generate really, highly relevant and contextual responses. So that's, to me, is what is truly impressive, and an impressive feat by AI engineering, right? So we can really start to see that brilliance shining through. And Abhilasha, I think the next slide I'm going to turn over to you and let you kind of talk about the MMLM architecture a bit.
Right. Thank you, Scott. So, like as you rightly said, we have these three main components, and in the next slide, we'll see an example basically. So, this is the architecture which is followed by Lava 1.6, which is one of the VLMs. I would say it's an open source VLM. That's how we know the pieces which go into the making of this. And this is where we have the vision encoder, and this part is our text encoder. Now, the vision encoder will take in the input as your image, which is in the form of pixels, and it will be the combination of RGBs, which will be broken into segments of the image, and then that will be encoded and converted into a vector structure. Now, this is a set of embeddings, which is from the space of this model. So in this specific case, it is a model called CLIP, which is a vision model. And then on the other side, what you see is our, like traditionally how we work with input tokens and the position of the text, using which we generate the embeddings, which gives us the context of the content which was fed into the model. Now, like when we actually process a normal LLM also, we would use these embeddings, which will go into our language model. But now the difference is, and like if you think about the context, right, why they have pieced it together is because they are trying to make use of already established pieces. So if you talk about CLIP as a vision model, is a very established and state of the art model. Then we have Llama, which is a LLM, which is again a state of the art open source LLM. Now, all these things are already established, so we are putting these together and creating a structure for our VLM. But the only difference is, since these are already existing models, they have their own embedding space. That's where the adapter becomes very important, as Scott mentioned, right? So the projection layer, which will ensure that these two set of embeddings will be mapped into the same embedding space, so that the semantic similarity will map together, and then both the text and the image content is actually making sense to the LLM, so that these embeddings after the projection gets fed into the LLM, and then the LLM would traditionally, it will predict the next token or the next vector, which will get decoded to the language. So that's how we will get the text output. And this is what VLM's architecture is all about, where we are bringing in already working pieces and making them work together to achieve the multimodal behavior. So moving on, yeah, so we know like there are many providers of multimodal traditionally. So like some of these old names like DeepMind, Flamingo, Salesforce, Google Palmy, and then some of the recent ones like Gemini, GPT-4 vision model, Claude 3. So these are some of the existing VLMs or the multimodal languages, which different companies are venturing into, and like we keep hearing of new models, right, Scott?
All the time. Yeah, you got it. I mean, when you look at this list, right, it's pretty impressive, right? So you got things like, I mean, just look at the list. DeepMind's Flamingo, like you talked about, the Blip, and we got Google's Palm. You got Google Gemini. You got Cosmos One from Microsoft, and of course, we're all familiar with, OpenAI's ChatGPT and ChatGPT Vision. But then you've got Claude 3, right, that we've seen quite an uptick in. That's from Anthropic, and really you also got Lava, right? So which stands for large language and vision assistant, right? So it's really, to me, it's an impressive range of companies and organization that are working on these cutting edge technologies, right? So it's not just one company anymore, right? It's several companies of different sizes that are working on these things, and they really bring their own unique capabilities and focus areas to the table. And I think we'll probably even see that in some of our demos, how some handle things a little differently, some better than others in some areas. So it really gives us a good range, I feel, of different models to choose from, based on what application you're using. So, we tend to think about, GPT-4 vision model from OpenAI, which has made, significant strides really in natural language understanding and generation. So it's exciting to see how these different platforms are pushing the boundaries, really, of what's possible out there in multimodal AI. So pretty impressive what's going on, and I suspect this ecosystem will just get deeper, but also even broader, right, with other companies developing models. So yeah, I agree.
Absolutely, absolutely. Yeah, so I'll just quickly go over the slide which I had put to give a view of, if you look at GPT-4 vision or Gemini, the vision models. So these big companies who have brought in this model, they have definitely not disclosed the underlying architecture or the underlying models which they are using. But then, as we saw, like Lava V, and definitely these also would have something similar. Maybe they would have like tried out some different combinations and like tried to bring in that efficiency. But then deep down, there has to be a visual element, like we saw the clip. So it is a 14 layer model which is used in Lava 1.6. And then there is a different variety of large language models which are used like from Llama. And then these are like fine-tuned versions of Llama. Then we have Mistral 7B. And then there is a Hermes model also, which is a proprietary model of the company which owns Lava. So just like bringing out different variations to like variations from the size perspective, so that the parameter size which we see here, like 7 billion, 13 billion, and then accordingly the like the capability of the model will also vary, and the computational needs will vary. So based on, so this being an open source model, like you can deploy whichever version is suitable for your computational availability and requirements, right? So that's where this slide is just to give you a view of that. And yeah, moving on, I'll quickly talk about this before we can more like delve into details of more how we can use these multimodal large language models. And essentially, like as we know that there are two elements, the text and the vision component. So that's where we, here we are trying to give a representation of, since there's text, we are doing some NLP related tasks. And since there is a vision, that an image input, be it a video or an image, there is some sort of computer vision tasks which also come into picture. And that's where, like if you think from NLP perspective, you have like summarization or description generations, good storytelling, question answering, or just this computer vision task where you're trying to generate, like understand the visual and generate the visual also to some extent, if not in the current models, but then definitely we will see the future where we'll have the same model doing all the things till generating an image also. And then we have the reasoning, understanding the image, and then trying to like reason and get the analysis out of it. And then navigation, where you're actually dealing with the spatial information, understanding the different aspects of the vision and combining it with the text aspects. So that's where these three flavors come in. And then, so yeah, if you talk about this, would you like to take this, Scott?
Yes, sure. Be glad to. So as we look at this slide, and we start to take a look at take a bit deeper dive into the specific tasks, if you will, that fall under each category. as we see on this slide. We'll start with like generating, generation tasks. And with this, we have, visual question answering, visual captioning, visual common sense reasoning. So these tasks involve generating textual responses or descriptions based on visual input. So they leverage the model's understanding of both modalities. And when we look at the classification task category, we see that the multimodal effective computing, we see natural language for visual reasoning, and these tasks involve classifying and categorizing multimodal inputs based on their context and relationships. So, and then finally, as we look at retrieval task category, we've got visual reasoning, vision, language navigation, and multimodal machine translation. And so these tasks, they involve finding and retrieving relevant information across different modalities, such as images and videos based on a textual query or prompt. And I think we've got an example later that will show that quite nicely. So as we look too at these these next set of categories, or next set of examples in these categories, it's kind of worth noting, that while these task categories, they provide useful frameworks for understanding the capability of multimodal language models, there is often an overlap and an interplay between them in real world applications. So in a kind of example of that would be systems that performs visual questioning, answering, may also involve elements of retrieval and classification. So as we start looking at at these and taking a little bit deeper dive into these, let's look at again, kind of going in the same order we did earlier on the previous slide. So under generation tasks, we have examples like image captioning, which involves automatically generating descriptive text for the images. We got video summarization, and that's where the model can create concise summaries of video content. And you can think of so many different applications that could be involved with that, right? And then automatic translation with content that leverages visual context to improve the accuracy of machine translation. So as we move on to classification tasks, we see that content creation for social media, where multimodal models can help generate engaging posts that combine text and visuals, medical diagnoses for medical images and reports, using the model's understanding of both modalities to aid in diagnostic tasks, for example. And then finally, under retrieval tasks, we see a slide on the slide. It mentions visual questioning, answering, visual question answering, and also it allows that allows users to ask questions about an image and receive relevant answers. So you can actually query and ask questions about the image that you're seeing. So pretty impressive. And then interactive learning platforms are another example, and that can provide personal content based on multimodal inputs, and enhanced search and retrieval systems that can find relevant information across text, images, and other modalities as well. So I know it's really, to me, really exciting to see such a wide range of multimodal models across the different categories. And I can tell you, even what we work with within Walking Tree, it's interesting to see now all the different use cases that are starting to pop up. And I don't think we can even fathom those even 3-4 years ago, right? We couldn't even fathom some of the things that we're starting to see now. So I think what you'll see is these lists are just the launching point for what we're going to see in the future with them. So Abhilasha, you want to talk a little bit about VLMs versus the traditional models, or if you got something else to add here, feel free to chime in.
Yeah, sure. Sure, Scott. So you covered the use cases, and we saw some of these things were traditionally done by, like the traditional models, we had specialized for, say, image processing or data extraction or object detection. And that's where, when we bring in these VLMs, we have to take a conscious decision whether we really want to take that use case with the VLM, weighing the pros and cons, right? Because it comes with an extra cost, like depending on whatever, like if you're hosting a traditional model, you're already doing image processing. So why would you go for a VLM? Now, definitely the edge which VLMs bring in is a much more understanding and you can say specialization of comprehending what is going on in the image in conjunction with the text. So that's where, like when we talk about image processing, those models are specifically trained for some set of images. But now when we are talking about VLMs, that's like the entire ecosystem, and they have a vast knowledge base, they have a much better context understanding. So definitely they have a much more maturity in apprehending and giving the suggestions. But then definitely sometimes they could lack the exact or precision of response, which an image processing model would give, because it is precisely trained for that set of images. Similarly, if you're doing a data extraction using OCR, so again, we know there may be some limitations there, but you can actually do it faster. You're not dependent on the model latency and things like that. So it is a faster solution, definitely. But then with data extraction using VLM, we can bring in much more structure to the data, irrespective of whatever format we are getting the data. Because in OCR, we'll directly just extract it and it will be just a dump. But with VLM, we are able to give a proper structure. You can go with a JSON structure, you can go with a YAML structure, and using that data, then you can do your downstream applications, calculations, whatever it is. So that's the advantage in terms of data extraction, and we'll see some examples as we go about it. Similarly, for object detection also, since like the specialized models are trained with more localized data, so they can give better accuracy. But then if you're looking for a more wide context and a more wide variety to just identify and maybe count objects, so their VLMs do a pretty decent job. And we can, so definitely as we move on, we look at some of these examples. So in fact, maybe I'll talk about this use case wherein this is, if you are into stocks and trading, you would recognize this. This is a stock market chart from NSE, India stock market, and it's for a bank. And it shows a candlestick chart, the performance over a period of 3 months. Now, I tried giving this model to the Lava 1.6 model, which is the open source, which is like hosted on like one of the servers, and we can just try it out. So I was just trying to check how well an open source model performs. And you can see that this on the right side, this is the output, which is giving, I would say, decent results. It's able to identify what kind of features it has. It's also able to give some sort of prices, which were which were shown in the graph, and then some other statistics like moving average, RSIs. So I would say it gives a decent report of your image. So this is a very, I would say, a very useful use case where you're trying to analyze the chart and make some recommendations or make some analysis out of the data. The next use case, and this one I had tried on using the Claude 3 model, which is like a recent model of Anthropic. And it is a good, I will show some of the use cases in the demo part as well, where some use cases Claude does a very decent job. So this is one of the use cases where on the left side, what you see is a screen. So this is a screen taken from a Figma wireframe, and then I ask the model to generate the React code using Bootstrap, and then you see that it does a decent job, right? So, I mean, this is a good code to start coding with. So if you can save some time and effort. So that's where you can see that you can use the multimodal expertise of these models in various different ways. And as we move on, like we'll see more of it. So yeah, so this is another use case where we are talking about e-commerce use case. So like you're giving an input as an image where you're looking for similar recommendations. And how this would work is it would first analyze the image and try to extract the image description, which you can do with a combination of your GPT-4 vision model or any other vision model. Analyze the image and extract the attributes. And then based on the attributes, you do the similarity search on your product catalog. So all these different aspects, what you saw is searched upon, and then you would get a product recommendation of similar kinds of products. So this is another like use case which could revolutionize the e-commerce industry in different aspects. What do you say, Scott?
Yeah, no doubt. I think those are some really good and honestly compelling use cases. Among many others. It's kind of hard to settle on which use cases to kind of highlight here, to be quite honest. But I would say now that we've kind of looked at some of those use cases for multimodal language models, let's take a closer look at maybe when we're actually going to need or can benefit from using multimodal language models. So let's take a look at that and just kind of some bullets real quick. So as we see in the slide, one key scenario is when we need to analyze and generate content across different modalities, like we talked about before, like text, images, audio, and all those to gain a more comprehensive understanding and a richer output, right? So it's just getting a better context and more detail to work with, just like you or I, when we're somewhere and we're viewing something live, right, and we're able to process all those things and get a good comprehensive understanding of them. This kind of allows for that same type thing. So another important use case is integrating information from various modalities, again, so that we better understand the context of a situation or a conversation, and by combining those things, text, visual, auditory cues, multimodal models can really provide a more nuanced and contextually relevant insights for us. So also you see in the slide, we mentioned enabling, more expressive and more context-aware communication by incorporating, visual and auditory cues alongside the text. So this could be particularly valuable for applications like chatbots, virtual assistants, and even, accessibility type tools as well. So providing personalized experiences is another key benefit that we see here by considering, user preferences and contextual information and multiple modalities. This could enable more like a more engaging, I would say, and tailored interaction across really a wide range of applications. So you can imagine some of the, as you start to see these things and think through them, just the use cases that start to pop. Just a lot of them. For me, it just probably too many to list for me. So so I'm ready to go as far as that goes. So and I think, of course, multi-language models can be incredibly powerful for facilitating things like search, right, and retrieval tasks. So by understanding the queries in one modality and retrieving relevant information, from different modalities. So finally, to kind of wrap up this particular slide, we mentioned supporting users with like disabilities by interpreting and generating content across different modalities to enhance accessibility. And this is really an incredibly important and impactful use case here that could really make a difference in people's lives. So it's not just some novelty anymore, right? It's not just something cool, but it's also something now that we're starting to see that can affect, people's lives and their ability to live life in the fullest, right? So, to me, it's clear that, the multimodal language models, they've got potential to transform a wide range of application and industries. So not just one domain, but various domains and industries. So by enabling more comprehensive, contextual, and accessible interactions with data and content, we really open up possibly a whole new part of life for some people. So now that, and I'd say now that we've taken a look at some of these key strategies for adopting these technologies in like an enterprise setting, let's look at this next slide. So the first strategy mentioned is data integration and pre-processing, right? And that involves like collecting and pre-processing data from various modalities. Again, like we mentioned before, text, image, audio, and it provides, good compatibility and consistency, right? And this is a crucial step in building, an effective multimodal model. The next strategy that we see here is in model selection, right? So in model selection, this emphasizes choosing an appropriate multi-language model that effectively combines the information from the different modalities while maintaining, computational efficiency as well. And with integrating, with existing, integrating within existing systems is another key consideration, right? So we want to ensure that the multimodal language model can be seamlessly integrated into, an existing production system, workflows, and that enables, again, compatibility and interoperability as well. So how do we really use it real world and with what we have now? Abhilasha, you want to talk a little bit about data privacy and security in respect to multimodal language models?
Sure, Scott. So data privacy and security being like a very important aspect where you have to make sure of you're taking care of the different requirements of your system, protecting the sensitive information. So if it's a multimodal data, you have to be extra careful because you have images and text, wherein if there is a need for any, you can say data anonymization or blurring in the image. So accordingly, that will have to be done. Similarly, on the aspect of when we are taking any model to production, there has to be a proper pipeline set up with monitoring and maintenance, with proper feedback loop, so that you're evaluating continuously how good or bad your model pipeline is performing, and then taking necessary actions on maybe for the fine tuning it or replacing it with a different model. So that's where the feedback, ensuring the user experience becomes important. And finally, like taking care of the industry standards and the regulations, again, is I would say it is mandatory in any LLM application, and so is in this case, because definitely where we are handling with data, we have to ensure that we are taking care of the compliance needs of how we are supposed to handle the data. And when you're taking these models into production, it may not be like a simple pipeline. There may be multiple components or multiple parts to the pipeline. So we have to be extra careful on how the data is getting transferred and how it is getting used. Right. So with this, we come to the end of the presentation and we'll move on to the demo. So I'll start with some of the Colab notebooks where I've tried out the Claude. model specifically. And then Scott, you can go over our Intellexy to show how we are using
Yeah,
GPT-4
sounds
vision
right.
model there, right? So yeah, so just let me know if my screen is visible.
Yep, we got you, Abhilasha.
Okay. So are you able to see my screen?
I am. It kind of shrunk down, I think, and maybe you want it to be a little shrunk down.
Yeah,
but that's fine.
I'm kind of looking at the collab notebook. And just give me 1 minute.
But yes, we do see your screen.
Yeah, I think now I should be able to. Yeah, I somehow struggle with this. Oops, I'll just reconnect. So I have run this before, so we can see the outputs already. And then these are some of the images which we'll be using for the demo. So like I've picked up the app screen, which I mentioned, and then there is, yeah, then we have like a financial chart. We will be using a bill of lading, which is a kind of document which comes in different formats, and that's where we are trying to bring in the standardization of format. So yeah, so like after we install the required libraries, so we are using the Claude model, so we would need the Anthropic libraries here. And then we move on to initializing our model. So basically, since this takes image as one of the inputs, so we have to like convert it to a base 64 bytecode, and then that image gets input as one of the inputs to our model. And then we send the message list. So basically, it's like you have the image and you can have your multiple prompts as a list of messages which you can send to this model, and then it will like process all of that, and then it will send you the response. So to start with, like this is the image of bill of lading. And as you can see, like there are different attributes which are covered here. So what we are trying to do here is, so if you can see, you give the resource as the image, as one of the, like as part of your message list. And in the image, we are giving the BOL, let's close this here. So the BOL image, which is this, you just saw this bol2.jpg. And of course, it handles JPG, JPEG, PNG, the different media types. And then you would give the prompt of what you want, what you're expecting the model to do. So extract the details of the bill of lading shown and represent in JSON format. So I've given a small prompt here, but then definitely if you're doing for a real enterprise use case, you would have to give like the specific structure, you would bring in more control. And in fact, that you will see in Intellexy what we have tried to do. Now here, without the structure also, the model has given, extracted the content and then given the different aspects. So you can see like the shipper, the bill of lading number. So these things are getting extracted. Similarly, if you look at the next case, so this is a chart. This is a Power BI chart which we are using. And what we'll try to do is, we'll see how well the model understands this chart, and whether if I ask questions about some specific figures, is it able to extract the value. And this is something where I would say the Claude model performs really well. So Claude 3, and we are using the Opus model. So there are three flavors to it, and Opus is the best one. So that is what we are using here. So we provide the chart, and then the first question is just like, what is the given chart about? And then it gives a good analysis, like it's a monthly policies and claims chart, and then you can see what all you can see. It's giving a summary of that. Now, what I did is I've asked specific questions here. So just to check like how well it's able to pick up the numbers from the different colors in the chart and all, right? So we are asking what was the number of policies, what was the total claim amount through like a call center sales channel. So if you see here, here you see the number of policies by state, and then here you have by sales channel, what is the percentage, and by location code, like rural, suburban. So we have tried to ask for urban and suburban, and you can see that it is able to like give the data. So number of policies in California is 9.3K, which is you can see here it's 9.35K. So it is giving the information, and it is also giving the source. So from which section of the chart it has derived that data. So that is bringing that extra credibility factor as well for the model, right? Another example which I picked up is like this AWS architecture, just to see how well it understands. And it was able to give me a good explanation of what the what the image is, what are the different parts of the image, and then the architecture, whether we are using a text tract, and then we have a human annotation component. So it's giving a good explanation. Again, yeah, this is the same use case which I showed you. So again, here I would say that Claude fares better, and you can see the report for yourself. So it's identifying the chart, and of course I've like given some special prompts here to think step by step, analyze the data, and provide your thoughts. And it is exactly what it's doing. It is giving an analysis of what the data is, it is giving the performance thoughts, and it is giving a final summary of how the stock has been performing. There is a intraday volatility, and there is a short-term bearish trend. But so you can see like it is analyzing with a very basic prompt. I mean, I have not given much instructions in the prompt, just to think and come up with the analysis itself, right? So similarly, like this was the example I showed, where we have given the screen and the wireframe and asked the model to generate the code here. So the code is generated, and it's a React component. And then you can see the different elements of the screen, which are like, you have the forgot password, you have the different 3 types of sign in: Facebook, Apple, Google. So you can say that it's a decent work here as well, and then it gives some explanation which you can further control. And another flavor which I'll briefly touch upon is like analyzing the balance sheet of a company. So this was like a PDF document. So we can take a PDF as input and then convert it into images. So this is the PDF, and then we convert it into images here. And then we can ask questions on top of that. So looking at the balance sheet of the company, can you analyze the different parameters? And you can see that it is, so let me just quickly show you the balance sheet. So if you can see the balance sheet of this company, and then so this is what the model has analyzed, and it has come up with its analysis, and then a final overall summary of how it has been performing, what has updated, what has gone up, what has gone down. So definitely like Claude is performing well in some aspects where it has to understand charts and understand financial documents. Now we'll look at how we have implemented in Intellexy. So there we've used the vision model. So I'll just stop sharing, Scott, so you can start sharing.
Okay, thank you.
Sorry.
All right. Abhilasha, you can see me?
Yes, Scott.
Okay, very good. So what we'll do is kind of like Abhilasha was mentioned, this is in Intellexy. This is our, our platform that we use basically to upload documents and retrieve information using, multimodal models. And like Abhilasha was saying, she was using Claude here. And currently we've got this plumbed up against ChatGPT 4V. So the vision model here. So what we're going to do is I'll kind of walk you through, the tool itself. And this is kind of a front end we put on this what we call IntelliXy, the code behind it to be able to take an image that's uploaded and then of course process that image based on certain categories or ontologies that we set up for it. So I'm going to take a look real quick and let's just look at, let's look at this first category, this vision category. And we can kind of walk you through what's being done here essentially is we have different categories. Like I said, I picked vision for this one. And what we do is we come up with a conversation ontology or conversion ontology. And as you can see, we try to put things in here so that, hey, it knows exactly kind of how and what we're looking for and how to format it. So, in this one, of course, the objects present in the image, count of the object in the image. So you can put different things in here depending on what you're trying to look at, right? And in this case, you can see it's very much geared more towards, looking at an image, doing analysis on the image and gathering information from the image and the statistics and so forth. So as we submit this, and by the way, you've also got prompt instructions, so you can kind of tell the language model that, hey, here's your prompt instructions. So here's kind of what we're looking for, how we're going to, kind of the overall process of what we're doing here to really process the image. And what we really do in the back end is we create a JSON output in this type format. And then in this tool, we just happen to say, okay, for those who don't want to read JSON, we've got a UI that can kind of display what was seen. So we'll walk through some examples of those. And like I said, this is for one category. Oops, let me go back to my categories. But you can have things like the scanned documents. Abhilasha was mentioning, the bill of lading extraction, which we'll take a look at. And you can see here we've put a little more depth into the conversion ontology, specifically around looking at a bill of lading. Okay, so looking at different things in the bill of lading and saying, hey, these are things that we know we might want and how we would want to format the text that you pull from that bill of lading. So in this tool, we have different categories that we set up depending on what we're doing, right? And so what we'll do is go through a few examples. We've already gone through several of these, just kind of preparing for this. And I think one we'll start with, Abhilasha, you just want to start in order? Want me to start with that bill of lading too?
Yeah, we can take up the bill of lading example. And in fact, like I would like to add one thing here. So
Yeah,
if
sure.
you look at the aspect of extraction here, so we are making use of both the vision model as well as the turbo model to improve the accuracy of the extraction. Basically, like if it is a scanned image where some part of it would be good with just the OCR, but then first we extract the OCR and then we bring in maybe if there is some handwritten content, or if you want to do some like extra, you can say analysis out of the data, then we bring in the vision model, and the combination is what brings this extra power of conversion into the format which we want. So that is our conversion ontology, which gets used internally, and the two models, like the vision model as well as the turbo model. So we can look at the bill of lading, which we had uploaded.
Oh, for some reason I'm not able to upload in
So
my
maybe we
browser. Let
can
me
look
try
at
to.
something which is already uploaded, Scott.
Let's see. I think I got it. There we go. There's the nut. Just pulled the diagram up. Okay, let's see. Maybe because I'm looking at a section. Let me kind of sorry. Let me pull out of my. Yeah, I don't know why it's not. So maybe we can look at the existing one. Sorry about that, gang. Not my browser, something's going on there. All right. So let's look at one of these. Abhilasha, you wanted to take a look. Any idea for like that bill of lading?
Yeah. So we can actually look at, if you go down, you can pick up the bill of lading, any one of those, or we can look at, maybe you can, yes, this is fine. So this is one of the documents where we extracted. So you can see the difference, like the first section is what the extracted content. And if you go with the normal OCR, that is what you will get. Now, with the bringing in the power of your language models, you're actually formatting it and giving it in a proper structured format so that you can now take this data and put it in a database, or you can use it for some further analysis, right? So that's where the structuring helps, and irrespective of how many ever input formats you go with for a bill of lading or whichever document it is, you can bring everything to a standard format. Now we can pick up the financial chart, or maybe the math example, math 1.
Sure.
So yeah, just to show like the reasoning skills of this model. So here this is actually a image with like a problem, math problem, and this is just extracted the OCR. But we can show the agent flavor of it, where actually what we've done is the model is extracting and it is putting the images. Now we are building a query agent on top of the model. So we select the math one here, maybe. Yeah. And then you create agent. And then we just ask to solve the problem. So it takes a while.
Yeah, it's going out to GPT, Chat GPT, basically.
Yeah, vision model. That's
Vision
where I
model.
took a simpler example.
There we go.
Yeah. Yeah, so this is one use case where, I mean, it's not a straightforward addition or subtraction. The model has to understand the pattern of the calculation and then try to depict. So you can see that the GPT-4 vision has a good reasoning, and it is able to analyze the pattern, and then it is giving you the details, and then it is finally giving the correct result. So, and in fact, yeah, this was one use case where Claude was actually struggling.
Yeah, and I don't see, for whatever reason, I was looking for that math one PNG. I don't have that one. I would have shown basically, sorry, gang, basically what that, this math one PNG, we can actually look at that though, can't we? If we look at documents, so we can kind of compare that. Math one. No, we can't see the raw doc or the scan document. Never mind. Okay.
Yeah, so
but
we have the
essentially,
problem here. Yeah.
yeah, essentially it's just got those problems written out just like you saw them there. It just lists these out on different lines. So it was a scanned document basically that showed this math problem. Then it was able to solve the problem. So yeah, sorry, I was going to show that. Anything else you want to show on agent?
Yeah, we can pick up. So yeah, for financial charts, like GPT-4 vision model, like did not give a very detailed response. So maybe you can ask to explain the chart, and then we can see how it works. Explain the chart and its parameters. So this question is actually using the vision model in the background and trying to give the answers. And yeah, that's the GPT-4 vision model. So that's where like we've tried to cover the two flavors. The first thing which we showed was the extraction, where we're actually doing a controlled extraction and conversion. And here it's more free flowing. You can ask whatever you want to. and yeah, this is the analysis you get. So it's actually
You can see
explaining.
a
So this is the
difference. If you
financial
remember, the
chart.
Claude model had a lot more details in terms of the numbers and everything, right?
Yeah. So yeah, so this like GPT-4 just gives you like a generic information, but it doesn't give the very specifics. And in fact, if you ask for recommendations, it will just say that I cannot provide you any recommendations. So yeah, so that's the difference in behavior, and that's where, like for your use case, you will have to see which is the most suitable multimodal language model, which will suit your domain and your problem statement. And additionally, you can fine tune that with your data, with your image, and with your text mappings, and then you can get a further improved version of the multimodal which works for your use case. So yeah, so that's about the demo. Any other thing you want to show, Scott? So we are actually already out
Yep,
of
we're actually at
time.
the end.
Yeah.
So we might just want to take a little time and talk about
Look at the question.
yeah, look at the questions. Exactly.
Yeah, so we have several questions in the chat box. I can see the first question, that is, can regular polygonal figures be used for vision encoding? Need not be RGB based.
So like that will depend on the vision model which we are using. But as an image input, like we can give any input, like be it polygonal figures or like factory charts, any kind of image can be given. But yeah, definitely it would also depend on what vision model the multimodal language model is using.
All right. So another question from Sanjay. He wants to know whether we will be able to send the recording. So yes, Sanjay, will be sharing the recording of this webinar. You will be receiving it over the mail, and we will also upload it on YouTube. So you can have a look at Walking Trees channel. It will be uploaded on Monday. Next question by Sanjay is: Can cloud model be? Can cloud model in do we need to program in Python, or it is uh, there a UI? So that's the question.
Yeah, so the Claude model is like you have a playground, just like how you have for ChatGPT, all the OpenAI models, right? So you can sign up in Anthropic, and you can actually get access to the Claude models. And of course, with programming in Python, you will get more control on how you're using it. But yeah, definitely you can play with it on the UI using the Anthropic login.
Okay. So next question is from Rick. He wants to know what are the implications for the latest developments in synthetic data generation for training more robust and diverse multimodal language models.
Yeah, absolutely. So this is one, like I would say like a very hot topic where we are using the synthetic data generation to generate data to further fine tune and train the models. And this is an active uh, research topic, as well as all the models are. So when you have to build domain specific models, definitely with the help of synthetic data generation, you can generate the volume of data which would be needed to train these kind of models. And definitely that is being done in the industry actively.
Yeah, and as a matter of fact, we had a first webinar on a topic related to that a month or so ago, and we'll even have one next month where we're using Unreal Engine, the gaming engine, to generate that synthetic data. And so next month we'll actually have a webinar where we're and I think we've entitled it something like "Enhancing Drone Inspections with AI-driven analysis. But even with that tool, and I think even in that webinar, we'll be talking about, you know, generating that synthetic data and how it can be used in training models, just like Abhilasha said. So there's lots of really neat things are going on in that space. So even using, you know, a gaming engine like Unreal Engine to be able to generate that synthetic data. So yeah, it opens up lots and lots of possibilities and gives us data that, goodness, we couldn't have thought about even getting at some point. It would have been very difficult to generate or get the data and analyze the data to even to be able to use it. So yeah, a lot going on in that space, Abhilasha, for sure.
And thank you, Scott and Abhilasha. So next question is from Albert. He wants to know, how is the concept of digital twins being integrated with multimodal language models for advanced simulations in industries like manufacturing and healthcare?
Right.
I think
Yeah,
Abhilasha, I'll try to take the kind of the manufacturing where I foresee some of that, you know, some things
sure.
happening there. And I think one thing is, I think it'll enable, you know, kind of more nuanced simulations in the you know, in the manufacturing process itself. So you can start looking for potential issues before they become issues, right? And maybe suggesting maintenance. So kind of even suggesting maintenance, or even, you know, where you can avoid downtime. So I want to say predictive maintenance, but hopefully even pre-predictive maintenance. So it'll even do it for us at this level, as opposed to even taking input from, you know, sensors and things like that, right? So maybe able to just look and take a look at things and be able to look at the context and realize some of those things. And I think too, just being able to observe processes, so doing optimization, like process optimization and so forth, kind of like an industrial engineer probably already does, a process engineer already does. And this would give even those type folks, you know, an extra pair of eyes in, you know, optimizing processes on the manufacturing floor, for example. And then I think too, I don't know, probably some things around, you know, being able to more quickly adapt, right? When you need changes in the manufacturing process, manufacturing floor, being able to use technologies like this, you know, could mean a lot more, you know, could mean a lot more dynamic response, right? To when market changes and those kind of things happen. So that could really, I see it being able to significantly shorten that design cycle when we need to enhance, you know, some product or something too, right? So that's just a few in manufacturing. I know healthcare. Um, Gosh, there's kind of around some of the same things. I definitely see in terms of training, and even training, you know, training models to some degree, right? And being able to look at things and use this type uh, multimodal models to be able to look at images and also, you know, have some representation of, well, what does it really mean? What's text bashing that up against, you know, what they're seeing in even a medical image, for example. Training, and I think just training and educational areas that this can help with as well. Even analyzing even real life situations for them, right? So I think lots of areas around that, around patient care, treatment simulations, those kind of things, probably too. Um, Probably able to provide a more personalized medical plan or therapy plans and those kind of things as well, instead of just following a certain script or a process that a therapist or even a doctor or nurse would follow. So I think a lot of advancements in terms of that, and even kind of relating that back to the digital twin concept in manufacturing, right? Kind of the same thing with looking at efficiencies even within, you know, the healthcare process itself. It may be product patient intake in a hospital, or how, you know, how they're going from patient to patient and analyzing the patients and writing reports and so forth. I see this kind of tech even improving operational efficiency, even in a medical facility like a hospital, for example. Abhilasha, anything to add to that?
Yeah, I think you've covered, Scott, pretty much. So, standardization of medical documents, or even analyzing the reports. Uh,
Yeah.
we can have specialized models for that as well. So basically, digitalization of the entire process, be it a manufacturing factory diagram or medical reports.
Yeah, and even tying back into that synthetic data part of that in the medical industry, right? Being able to use things like that Unreal Engine to model even certain anatomy, right? To be able
Right,
to
right,
say,
right.
okay, let's generate those things, let's generate synthetic data, and then using multimodal models to analyze that, as well as maybe different medical documentation, right? Whether it's case studies, those kind of things. Just gosh, so many different applications you can think of.
Absolutely.
Just need someone with the willpower to say, okay, let's go do this, right? Don't be afraid to innovate. That's really kind of what it comes down to here. So, and obviously when we're talking in these spaces, manufacturing and healthcare, there's some real world things, right, that can happen and go badly. So yeah, you gotta be careful in how you utilize these, like anything, right? You talked about security before, even, right? Privacy and security. I mean, and especially around the diagnosis areas too. So, but those things are beginning to be well known, and we know, when the models are off and so forth. So so yeah, it opens up a world of whole new world for, I think, manufacturing and healthcare in that respect. Hopefully that answers the question. It's a long-winded way to answer that question, but
Yeah, so that was our last question today. So
all right.
I would like to thank both the speakers for sharing your invaluable insights. So before we conclude, I am excited to announce our next webinar, which is scheduled for 18th of April, titled From Simulation to Reality: Enhancing Drone Inspections with AI-driven Analysis. In this upcoming session, we'll be exploring a fascinating intersection of simulation technology and artificial intelligence, focusing on how these advancements can revolutionize drone inspections. So, thank you everybody for your active participations. We look forward to welcoming you to our upcoming webinar. Until next time, everybody, stay tuned for our further updates. Thank you everybody once again.
Yeah. Thanks, Taniska. Thanks, everyone.
Thank you.